Probability, combinations and permutations. To work in this section, we need to define a number of things. The first one is the term factorial. Factorial is a very small symbol, the exclamation mark, and it's a shorthand for saying multiply the number by the number less than it by 1, by 2, by 3, all the way down to 1. So if somebody says, what's 3 factorial? It's 3, starting with the number, times 2, the number less than it, times 1. It's always to do with integers here we're talking about, and you go 3, then 2, then 1. You don't multiply by 0, because that will make everything 0, and that gives you 6. N factorial is defined all the way down from n down to 1. 5 factorial is 5 by 4 by 3 by 2 by 1, 120. And 1 factorial is 1, and 0 factorial is 1 as well, by definition, on your calculator. We don't talk about minus 1 factorials or whatever. The next term we define is a combination. And a combination is a selection or a number of objects in any order where the order is unimportant. I'm going to have a watch and a football. I don't have to worry about which order they're in or anything like that. I'm selecting things from a total of n things. Or things, the number I want, 2 things maybe out of 4, or 1 out of 3, or whatever. And I can pick those. So there might be various toys or sweets. We might call them, say, just item 1, 2, 3, 4. Mystery items. And these are prizes. And they're seen as pretty much interchangeable, and you're saying you can pick 2. So you could pick item 1 and 2. You could pick item 1 and 3, item 1 and 4. You could pick item 2 and 3, 2 and 4, or 3 and 4. But if you pick item 1 and then pick item 2, and somebody else were to pick item 2 and item 1, you'd end up with the same things. You have both of the items, that's it. The order doesn't matter. You have it, whatever. So what we're saying is the order is unimportant, selecting these items from another. And it gives quite an impressive looking formula there that's in your tables. It's called NCR. It should be on your calculator as well. NCR, sometimes written in brackets like that on other calculators. N factorial, n minus r factorial, or factorial. And those are equivalent as well. N over r is n over n minus r. And we'll explain that as well. So if you're trying to get 3 out of 5, there's as many ways of getting 3 out of 5 as there are getting 2 out of 5, because, you know, there's a similarity. 4 out of 5 is the same as 1 out of 5. It's the many ways in which you're not getting it. So we'll work on those options there. The next item after that, just find the page, is permutations, where the order is important. The arrangement of a number of objects in a definite order, arranging all objects out of a total of n. The formula is similar to the one for C, but it's simpler. It doesn't have that or factorial on the bottom. So it's actually in the equation for C. It's exactly the same, it's in there, but it doesn't have the or. Which is a larger number, combinations or permutations? Combinations means that these are the ways in which we can put the 2 people on the committee. Permutations is this is the number of ways we can put them on the committee, with one being president and the other being deputy. The permutations means that for every way you start arranging them, for the 2 people on it, you can have one this way and the other, or flip them around. So permutations is a bigger number, or at least it's not going to be smaller. So permutations will always be at least as big as combinations. Okay? You might think of it being further down the alphabet, P from C, and a bigger number. Now here's an example. You have 4 very close friends. You get 2 extra tickets to a concert and would like 2 of your friends to come. How many ways can you allocate the tickets? It's a real killer. 4 friends, 2 tickets. How do you do it? Your friends are, in alphabetical order, Adam, Brian, Ciara, and Donna. Okay? Write down the number of ways you can get rid of the tickets. Adam, Brian, Ciara, and Donna. Saying A, B, C, D. Write down the patterns there. The first one is A, B. I leave it to your rest to do the same. Write down the number of options you have there. So returning to this, AB, AC, AD, we could give Adam and Donna a ticket each. BC, BD, and CD. They're the only combinations of the 2 tickets, really, that are there. In that, if you give Adam and Brian a ticket, if you give it to Brian before you give it to Adam or vice versa, it really doesn't matter. They're both going to the match. Or they're both going, in this case, to the concert. Okay? 6 ways in total. Could we use a formula for that? Well, if we were using a formula for that, we would pull out our toolbox. And our toolbox here has a formula for C, NCR. So we're going to use that formula now. And we're going to say the formula would say NCR. N factorial, N minus R factorial, R factorial. Why is it a combination? Does it matter whether Adam gets the ticket before Brian? No. They're both going. Is that okay? So it's just who's going. Who's in the group. So it's a combination question. How many people are there in total? 4. N stands for the number of people in total. N in this case is 4. That's the full set of your friends. Close friends, sorry. Seriously close friends. How many are you giving tickets to? 2. R is 2. So it's 2 out of 4. So R is the out of number and N is the it's N or it's 2 out of 4. So now we just go into, our own space and we fill in the numbers. N is 4, that's our table. N is 4, so that's 4 factorial. Over N minus R would be 4 minus 2 factorial times 2 factorial. Because everywhere I saw an N, I put in 4. Or I put in 2, 4 minus 2 is that. So I now have that NCR 4C2 is equal to this. That's what this equation is telling me. 4 factorial, 4 by 3 by 2 by 1. 4 minus 2. 2 factorial is 2 by 1. By 2 by 1. And if I start cancelling those out, 2 by 1, 2 by 1. 2 goes into 4 many times. 2 by 3, 6. So it looks like this answer here of 6 ways in total comes out. We'll show that in the equations in just one sec. Here we see it. One done with the calculation, 4C2, or 4, 2 this way, 4 factorial over 2 factorial, 4 minus 2 factorial, 4 by 3 by 2 by 1, 2 by 1, 2 by 1, 24 over 4, 6. So that 6 is confirmed by the 6 we originally had over the 6 ways in total. Okay? Example 2. You have 2 gifts you'd like to give to friends. The first is a music voucher, and the second is a travel voucher. How many ways can you allocate the 2 gifts among your friends? So Christmas has passed. You have these 2 presents lying around. One was a music voucher, which was a bit strange because you don't use these anymore. And the travel voucher is still usable. How many different ways can you allocate the gifts amongst your friends now? Assuming the pairing starts with the same, you've got 4 people. You've got Adam, Brian, Ciara, and Donna. Now write out all the various sample spaces now, which are 2 tickets. Is it the same as the last time? No. Okay, I'll come back. Okay, Max? Yep. Imagine the pairing of basically, what was the question there? You were given music and a travel of MT, the music first. That's the sort of pairing. So one possible pairing is you could start with AB. You could give the first one to Adam, the music, and then the T, the travel to Brian. You could go AC, AD, CD. But also, in this case here, Adam and Brian got the music and the travel, but you could give Brian the music instead. And instead of AB, you could have BA. Instead of AC, you could have CA. Instead of that, you could have DA, then CB, DB, and DC. Are they all different? Yeah, they are, because the position is important, because the first position in the set before the comma refers to the music, and the second one refers to the travel. It does make a difference which one you get. Whereas before, they were just 2 tickets for a concert. Is the order important? Yes. Words like arrangement is a way of suggesting that the order is important. How many ways can the students be arranged in a line so? Arrange, order. Rather than how many ways can be selected, you're in. Arranged, order is important. So is the order important? Yeah. Effectively, we can see here that in terms of the music, you had 4 choices, A, B, C, D. And then in the other then, you had whoever didn't get the music, you had 3 left, 3 left, 3 left, and 3 left. I count that to be 12. Is that okay? So many different outcomes are there. I think if you look at it here, your gifts. Adam, Brian, Adam, Ciara, Adam, Donna, but also Brian, Adam. So for Brian, Adam, Adam, Brian, Adam, Ciara, Ciara, Adam, we've got our 12 in total. Now, how would we have found that without writing out the sample space and working to probabilities. You've got 4 friends, 2 gifts. However, the gifts are different, so outcomes will differ depending. So what we do now is, on these questions, is we start asking ourselves very precise things. 4 friends, 2 gifts. Is it 2 out of 4? Yeah, we've only 2 gifts to give. One of those numbers has to be n, and the other has to be r. N has to be the total, the big one. So how many friends do we have? 4. So that gives us the 4. And then how many gifts do we have? 2. Well, that has to be the r, because it's 2 gifts out of 4 to be divided amongst them. Is that okay? So we know r and we know n. Does the order matter? Yeah, would I prefer to get the travel versus the other or vice versa? Does it matter? Does it make a difference? It does. If it makes a difference, is it combinations? No, it's permutations. Is that okay? So that means it's the letter P. So we now use the formula, and the formula from our toolbox is NPR is n factorial over n minus r factorial. It's exactly the same as the C one without the r part, though it's not given in the tables. So the formula says NPR is n factorial over n minus r factorial. So you use the permutation 2 out of 4, 4p2, npr. 4 factorial, that's our n factorial, over 4 minus 2. 4 by 3 by 2 by 1, 24. 2 by 1, 2. 24 over 2 is 12, 12. Is that what we were expecting? Another way is to multiply 4 times 3 on the basis that there are 4 ways of allocating. I think I was seeking to do that a moment ago. Where did I put it? I don't know, I lost it, I think. Yes, I think I put it here. There were 4 ways of allocating the first one. It could have gone to Adam, Brian, Ciara, or Donna. And the second one then, well, if it went to Adam, it could have gone to Brian, Ciara, or Donna. Brian could have gone to Adam, Ciara, or Donna. Adam, Brian, or Donna, or Adam, Brian, or Ciara. Many different outcomes are there. This was Adam, Brian. This was Adam, Ciara. And this was Brian, Adam, etc., all the way down, 12. So 12 options this way, 12 options this way, 12 options with the formula. It looks like it works. Hence 4 times 3, the multiplication of the first 2 terms. Now, we progress. A school, this is popular on the exam standard. A school student council needs to elect a female chairperson and a male chairperson. Ellen, Rachel, Beth, Sarah, Orla, Sheila, Brian, John, Stephen, and Matt are all candidates. Now, I hope we can work out the gender of those. They probably would make it easier because people have different names in different cultures. But I'm going to guess that Ellen, Rachel, Beth, Sarah, Orla, Sheila are girls' names, and that Brian, John, Stephen, and Matt are boys' names. Is that okay? So 1, 2, 3, 4, 5, 6. I've got 6 girls, and I've got 4 boys. The question for you is, the students have elected Beth and Matt as representative chair people. They must now elect a deputy female chairperson and a deputy male person. What's the probability that Stephen and Ellen fulfill these posts? Over to you. We'll give that a try. Give that a minute and see how you get on. Okay, let's give that a go. What's the probability that Stephen and Ellen fulfill these posts? Well, let's start at the beginning here. A school student council needs to elect a female chairperson and male chairperson. Ellen, Rachel, Beth, Sarah, Orla, Sheila. Brian, John, Stephen, and Matt are all candidates. So if we just take the first letter of the people involved, Ellen, Rachel, Beth, Sarah, Orla, Sheila, we've got 6 girls, and we've got 4 boys, or males and females, Brian, John, Stephen, and Matt. So we go through. The students have already elected Beth and Matt. So Beth is out of the picture, and Matt is out of the picture. They're no longer questions for us. So we're down to 5, really, to consider, and down to 3 here. The students have elected Beth and Matt as respective chair people. They must now elect a deputy female chairperson and a deputy male chairperson. So really, they have to pick not just from them all, but one of them has to be from here and the other has to be from here. The question is, what's the probability that Stephen and Ellen fulfill these posts? Well, what's the probability that Stephen and Ellen, I should have do that differently here, I'll do it a different colour. I'll pick Ellen first, P of Ellen here, and I'll say P of Stephen here. How many Ellens are in the green group here? 1. How many people are in this group? 5. So it's 1 meeting the condition out of 5 total conditions. It looks like P for Ellen is 1 over 5. What's the chance for Stephen? You see a 1 in 3 chance? There's 1 Stephen and there's 3 males, so P of Stephen is 1 in 3. What's the chance that they'll both happen? What has to happen here? Do we have to get Ellen and Stephen, or Ellen or Stephen? And. Is Anne making life more difficult here? Yeah, because, hey, we could get Ellen and not get one of the others. So actually it turns out that now that Beth has been elected, that leaves 5, and Matt took the chairperson's only 3, so 1 out of 5 chance left for Ellen, 1 out of 3, and it's and we multiplied the and, as we did in that fundamental principle of counting. 1 over 15. The probability in Ellen and Stephen to become deputies is 1 out of 15. We'll take another example now. Let's imagine that there are 5 girls and 4 boys are members of a social club. They wish to appoint a committee of 4 people to organise a group trip. How many different ways can the committee be formed? Well, we might just like to imagine the 5 girls, we might give them names or titles, G1, G2, G3, G4 and G5. And similarly for the boys, there are 4 of those, B1, B2, B3 and B4. Now they wish to appoint a committee of 4 people. So they're going to select 4 people for a committee. There are 4 places there. And they're asking how many different ways can they do it. Well, there seems to be no restriction. There's nothing about you have to have so many boys or so many girls. So when you're choosing, not only can you choose from the boys and the girls, but you can actually choose across the whole lot. So in this situation, we say, how many ways are there? How can the committee be formed? And the question is without restriction. If there are no restrictions, we say there are 1, 2, 3, 4 places. So or in this case is 4. And the number of people to choose from will be 5 here and 4 here, and 5 plus 4, because we can take any of them, we have n is equal to 9. So you have 9 people from which to choose 4. We then ask, is the order important? Well, we're not choosing a president and a vice president and a treasurer. We're told nothing about that. And we're just told, well, here we go. We have to pick 4 people out of 9. So it's a combinations question. So without restriction, we would say it's 9, from which we want to pick 4. So our NCR turns out to be 9C4. So using the formula, we get 9 factorial over 9 minus 4 factorial, 4 factorial. Writing that, we get 9 factorial. 9 minus 4 is 5 factorial times 4 factorial. 5 factorial and 9 factorial, well 5 is 5, 4, 3, 2, 1. and 9 is 9, 8, 7, 6, 5. The 5 bits cancel, so that goes into that, leaving the 9 by 8, by 7, by 6, because the 5 bits are common to both. And on the bottom, the 4 then becomes 4 by 3, by 2, by 1. So we look at that and we say, well, 4 times 2 is 8. 3 goes into 6 twice. So we end up with 9 times 7 times 2. So 9 times 7 is 63, times 2 is 126. So there are 126 different ways, 9C4 there with the factorials, 126 ways, unconstrained, of choosing the group. Now, we then move and we say, if the committee must contain at least one girl and at least one boy, what happens then? Well, we go back to the group again, and we say, we've got the 5 girls, G1, G2, G3, G4, and G5. And the boys, 1, 2, 3, 4. And we're told that we must pick at least one girl. So in this situation, there are 5 to pick from, and I want one of those. I can pick G1, G2, G3, G4, or G5. That will turn out to be 5 when we do the calculation later. In terms of boys, there are 4 to choose from, and we must pick one. So there are 4, we must pick one, and the order doesn't matter. I can pick boy 2 or before the girl or whatever, it doesn't matter. That means that we have chosen now one girl and one boy at least. We must choose the other 2. So the order doesn't matter, but how many are left? Well, we had 5 to choose from originally, here with the girls, 4 with the boys. And with that done, we can now choose anybody who's left. There'll be 4 girls left, 3 boys left, so this number then becomes 7. So the answer now becomes this times this times this. So for every one of the 5 girls I could pick any one of the boys, etc. So let's do the calculations. 5C1 is 5 factorial over 5 minus 1 factorial, 1 factorial. That turns out to be 5 factorial over 4 factorial times 1 factorial. And 1 factorial is 1, so that cancels. 5 over 4 factorial is 4 by 3 by 2 by 1. And when you divide that into that, we're just left with the 5 because the other parts fall out. So the first number is 5. That's for this. So that number gives us 5. 4C1, similarly, is going to give us, on the calculator, 4. 4 factorial over 4 minus 1 factorial, 1 factorial. 4 minus 1 is 3. 3 factorial is 3 by 2 by 1. Into 4 just leaves us with the 4. 1 factorial is 1, and we're left with 4. So this is the number 4 then, for the boys. And the last number is 7C2. 7C2 is 7 factorial on the top, 7 minus 2 factorial, 2 factorial. 7 minus 2 is 5. 5 factorial is 5, 4, 3, 2, 1. 7 is 7, 6, 5, 4, 3. So the only bits that's left, if we divide in, the 7 and the 6. So we have 7 and 6 over 2 by 1. 2 goes in there, 3, giving us 21. So in total then, we have a lot of options there from that. 5 by 4 by 21 turns out to be 420. Okay? And that's the end of that session.